Welcome 1100. We are doing fluids in motion today. Now, I have a lab manual dated 2018. It's the revised version. I saw a different version floating out there that's older and it's different than mine. It has actually more analysis, but whichever lab manual that you have, you will have enough data from watching this video to do the complete analysis in either case. So in my lab manual, the first part is just positioning this near a sink with the ruler placed on the bottom of the sink. Now, we don't even have sinks any longer in our labs. We provide you with a bucket, and we'll use a bucket or like a basin today when we do this. What we want to do is determine the range, the range that the water falls from the orifice to the ruler. Now, if you're doing this with like 3 people, it would be easy because you could knock out 2 parts in one. And what I mean by that is, as the water level falls, somebody is constantly watching the cylinder. So when it gets to a specific height, they would indicate that to the individual holding a timer to time, to record that time, and also indicate certain intervals to the person keeping an eye on the ruler to measure the range. We can't do that today because it's just me in here, so we need to do those 2 parts separately as outlined in your lab manual anyway. Furthermore, I can't watch this water level and the position the water falls on the ruler for the range simultaneously to get accurate results anyway. So what I'll do is keep an eye on the range and signal to you, the viewer, when to record the range. The camera will be positioned so that it's constantly on the ruler. It'll be constantly on the stream of water falling on the ruler. So we're gonna knock this out, I think, rather quickly, and it should go well. There are some distance measurements that we need, and let's see, one of them would be the water level. I'll use the reference point being the center of this orifice to make things easy. What else? The height. The height the ruler is from this orifice, the height. And to make those measurements, I'll walk you through how I'm going about getting some accurate measurements, but it'll be up to you to make those final measurements. In other words, I'll send you some photographs of the objects of interest that need to be measured, like not only the height, but the diameter of this little hole, and you're supposed to measure the diameter of this too. So what we typically set out are these calipers, and you use this to measure the diameter. So I'll send you a nice photo of this with, after I get this the correct distance, so that it equals the diameter of this tube. I'll set this on top of a meter stick, and I'll take 2 pictures of that. One of them will be on the left side and the other the right. So whenever I'm sending photographs of things to be measured, it's not just one picture, because there'll be air introduced in your measurement with there being only one photograph. I'll get the camera lens directly above the object, or position that you're trying to measure. And let's see. What's interesting is that they want you to use this Knott's Berry Farm looking thing to measure the diameter of this cylinder, but technically you would need the inner diameter. So I'll tell you what, I am going to measure the thickness of this cylinder, and that looks like it came from the log, right? So you could, if you want, you could determine the measurement of the actual inner diameter of this tube if you wish. So you're going to have a photograph of the vernier caliper that represents the thickness of this tube, and a photograph of the vernier caliper that I'll take after measuring the diameter of this orifice. So I'll make sure to use the same caliper that was used in your previous lab. I think it was lab 1 maybe? Because of course there's different calipers have different scales on them, and I want to keep, I want to use the instrument that you already learned or gained practice on. So I think I'll analyze this data when we're done with the video. Yeah, I for sure will, just to make sure that everything was done correctly. And if there's anything I think that you need to be aware of, I'll pass it along to you. So let's get started. I'll put you on pause. Okay, part 1. We are just going to do some basic measurements here. Now, your lab manual makes reference to H1, which is the bottom of this cylinder to the center of this orifice. H2 would be the bottom of the cylinder to the water level. And that would change throughout the experiment, right? Because it would be draining. But in your analysis, the equation calls for H2 minus H1. And that's assuming I'm not interchanging the H1 and the H2. I mean, they could have called H2 the distance from the bottom of the base to the center of the orifice, but I believe it is, they did call it H1. But anyway, they want the difference, or in your analysis in the equation, you will be taking the difference. So ultimately, what we need is the distance between the center of this orifice to the water level. And this cylinder is conveniently marked with lines along the around the circumference of the outer surface in 1 centimeter intervals. So the reference line 0 goes right through the center of this hole, this orifice that the water flows from. So we don't need to take those measurements for H1 and H2. When we do the third part, we are just going to measure H directly. Now, or small h correctly, because there's another H, a capital H, and that is the height that your water falls. And it's going to fall on top of a ruler. Now, your lab manual makes reference to a sink. Our labs don't even have sinks in them. So if you were to walk into the lab, you would have a bucket to collect the water. So I suppose it makes sense in your lab manual to say, just put the ruler on the bottom of the sink. But that doesn't work in the case where you use this basin here. And that is because as the water fills this will float and just float away, move around, and render our measurements useless. So put our ruler on risers so it's always above the water level in this container here. Actually, this sometimes bows, so I just put this piece of metal here and put this on top of the ruler so it's completely stationary. So I need the distance from here to here, but actually they're like grooves and little risers built into this. So this is going to be higher than the level of this desk here. So one way to measure this, or the way I prefer to do it, is to just use this here, and this is what I do. This rod here, I'm going to sit it right on top of the ruler. And tighten it. Bear with me. I'm trying to get it very accurate here. Okay, so that's all how the ruler is off this surface, and we don't care about that. Ultimately, we just want the distance from that ruler to here. So what I am going to do is line this up with that, with the center of that orifice. Now, let me put you on pause while I do that. So what I did was I put the camera lens, I centered the camera lens on that reference line of interest. Now, this line here is a reference line that indicates 0 centimeters, the line that we're measuring from, and this line goes right through that orifice. And that is where the lens of the camera is positioned, level to that line. So you can see that I put a piece of tape on this rod where the bottom edge of that tape is along the center of that hole, that opening, because it is along that etching. And I put the arrow there just as a reminder that that is the edge of the tape that we're measuring from. In other words, when you measure this, don't accidentally measure from the top of the tape. We're measuring from the bottom there. And that is how we are getting our height. So let me put you on pause. So we are now able to determine our capital H, or in other words, the distance between orifice and top of ruler. What you will do is measure the distance from the edge of this rod to the bottom of the tape. So I'll just place this on top of a meter stick and take some nice photos for you. A photo of the left side and a photo of the right side. I don't want to just take one photo, right? Because there'll be air introduced into your measurement. So I'll put the lens right above the edge of this rod and then right above the edge of the tape. And that is it for measurements. So let's get on to the next part. Okay, so we are ready for part 1. We want to determine the range that this water falls from this orifice onto this ruler. And there are certain points of interest that we want. We begin with the 14 centimeter mark and then we jump by 2s. So here we go. And I will let you know when we get to those points of interest. I'll say something like now. And you can pause the video when I say that and then record the position of the water, then continue to watch. So right now we are around 16, we're approaching 15, and we are getting closer to 14, and now, okay, so we just passed 14. We are getting towards 13. Okay, we are now approaching 12, and I'll let you know when we get there. Now, okay, so we just passed 12. We are approaching 11. We just passed that. Okay, we want to record it. Position at 10, and now. So that was 10 centimeters. So we passed 10, we're coming down to 9, we are passing 9, and we are slowly approaching 8, and not yet, but now. Okay, so we have a couple more to go, and the water is draining more slowly. So it's going to take a little bit more time. We passed 7, and we will eventually get to 6, almost there. And now, okay, one more to go. We are slowly getting towards the 5 centimeter mark, and we are passing it now. So your last data point will be at 4 centimeters, and I'll let you know when we get there. And now. Okay, so that is it, and I'll put you on pause. All right, here is part 3. What we want to do is determine the velocity of this water level as the water drains from the cylinder. Now, I have myself a passcode timer, and it only has the capability of recording 9 events, which means we're going to have to do this in a 2-step process, because what I'll do is start the clock at 15 centimeters. The first event will be the time when the water level reaches the 14 centimeter mark. Second event is when it reaches the 13 centimeter mark, and so on. So at 16 centimeters will run out of event storage. So we'll do this twice. Okay, so we have a bit of time now. It is nowhere near 15 centimeters, but approaching. So again, when it gets to 15 centimeters, I'll start the clock. Almost there. Okay, I started the clock. First event will be at 14 centimeters. Next event will be at 13. Next will be at 12. Next at 11. So I'm recording this at the right eye level so we get an accurate reading. Next one will be 9. Coming up on 8. Obviously it's draining slower now. That was 7, and our last one is 6. Okay. Let's get some data. So, at what time were we at 15? Obviously 0. First event, which was at 14 centimeters, was at 6.54 seconds. Then 12.67, then 18.93. So your lab manual has a table or an example table. It didn't put the appropriate number of rows. So you'll have to make your own data table. Let me make mine right now real quick. So we had 15, 14, 13, 12. Okay, so once again, 15 was at 0, the 14 centimeter mark was 6.54, the 13 was 12.67, the 12 centimeters was 18.93, the 11 centimeters was 26.94, and obviously these are in seconds. Event 5, which was 10 centimeters, is 34.68. 9 centimeters is 42.44. 8 centimeters is 50.96. 7 centimeters is 60.61. And event 9, which pertains to the 6 centimeter mark, is 71.00 seconds. Now, we need to determine the time it takes for the 5, the 4, and the 3. Let's start all over. So again, when we hit 15 centimeters, I will start the clock, and we're almost there. So I hit the clock a little bit too soon. I almost debated whether or not I should do this over. It would be good. so the clock started at 15 centimeters. In other words, as it approaches 12 right now, if I was to stop it, it would match what we already recorded, right? It's still draining at the same weight. But I don't care about 12 or 11, 10, 9, 8, 7, or 6 for that matter. I want the time that it takes to get to 5, 4, and 3. Or around 9. Okay, we're almost there. Coming up on 5. So I got 5. Now we're coming up on 4. And our last data point will be, or measurement, will be for 3, which I just got. Okay, so event 1 in this case was when the level reached 5 centimeters, and that is 81.57 seconds. 4 centimeters is 93.63 seconds. And the 3 centimeter mark is 107.48 seconds. All right, that was it for part 3. Let me put you on pause.